Hello, I'm Eugenie Scott, the Executive Director of the National Center for Science Education. In March of 1981, the Arkansas State Legislature passed Act 590, which required that if evolution were taught in the state schools, then something called creation science would have to be taught alongside it. The law was immediately challenged in federal district court by a group of religious leaders, parents, and education and civil liberties organizations. McLean versus Arkansas was the first full courtroom trial about creationism since the Scopes trial. The trial began in December of 1981. Stakes were high. The Arkansas law was only one of many similar laws that had been introduced in state legislatures around the country, and more were proposed. If the federal court were to determine that equal time laws were legal, science education would certainly suffer. It was important to staunch the flood of equal time laws with a strong legal decision. McLean was that decision. Although a Louisiana equal time law was the vehicle for the eventual Supreme Court decision striking down equal time laws at the national level, the McLean decision effectively stopped further efforts to pass statewide legislation. The plaintiffs brought a stellar cast of nationally known scientists, theologians, and educators to testify on the scientific and pedagogical worthlessness of creation science. The scientific witness team was composed of biologist Francisco Ayala, then at the University of California, Davis, geologist Brent Dalrymple, then at the U.S. Geological Survey, paleontologist Stephen Jay Gould from Harvard University, and biochemist Harold Morowitz, then at Yale University. All observers agreed that the scientific expertise, erudition, and clarity of these witnesses destroyed the argument that creation science was a secular scientific view that deserved equal time with evolution. The footage you will see next is from a 20th year reunion of these four scientists in a symposium held at the annual meeting of the American Association for the Advancement of Science in February of 2001. I had invited the four to reflect on how their scientific disciplines had changed in the 20 years since the trial, and how the growth of knowledge in the science might have changed their testimony had the trial been held today. We at NCSC hope you enjoy this historic event and that it gives you a better perspective on the importance of McLean versus Arkansas. Here then is McLean versus Arkansas 20 years later.
A funny thing happened to me in 1980. After having studied thermodynamics and life for 20 years, to almost no one else's interest, I found myself teaching thermodynamics in a courthouse in Little Rock, Arkansas, and having microphones from BBC and other such things put in front of my face, and being asked questions about this. This was, of course, the famous trial, Scopes 2, and I want to say a word first. You showed Judge Overton's picture. I don't think Judge Overton is with us anymore, but he did an extraordinary job as a jurist in running a very tight trial and making sure that everyone had their chance to talk, but no one had a chance to filibuster. It was really a quite remarkable performance. The topic that I testified about in most detail was life and the second law of thermodynamics. A number of the creationists had been arguing for some years that because of the second law of thermodynamics, life without divine help was impossible. That was rather interesting. That question had actually come up in the middle of the 1800s, when both the second law of thermodynamics and Darwin's theory of evolution came out within a 20-year period of each other, and this caused some confusion. Actually, Ludwig Boltzmann solved the problem around 1880, pointing out that because the surface of the Earth was a non-equilibrium object, and the sunlight, the low entropy sunlight flowing in could do work and lower, in fact, the local entropy of the system, there was no violation of the second law. And then in the 1940s, Erwin Schrödinger had put this in a slightly more popular and literary form in his talk about neg entropy and so forth. So there was no question if I were to retestify now on the same issue, I don't think anything has changed in the second law of thermodynamics. And that's the essence. And the second law, in terms of mandating disordering of the local system, does not apply to non-equilibrium systems, and that's the essence of my testimony. Although that had very little to do with the case. The essence of the case was the First Amendment of the United States Constitution, which was violated by mandating that a religious doctrine be taught in the schools as a scientific doctrine. But some interesting things have happened in the 20 years since the trial. Within science, the whole idea of the origin has become, well, for one thing, it's become much more of an experimental subject, having to do with chemical experiments dealing with the origin. But what has changed things even more is the development of complexity theory, and in particular emergence, have given, I believe, scientists a new take on the origin problem. That is, I think emergence, and by emergence I mean the view in John Holland's book Emergence, in which one starts with reductionist laws at one hierarchical level that generates, you can then model what goes on at that hierarchical level, and because you're dealing with a very large number of nonlinear equations, the whole problem becomes combinatorically explosive. This is something we had faced before computers, and had been a deterrent to the study of a lot of questions of that type. But what happened, and the point that Dr. Holland stresses in his book, and this comes about in computer modeling of these subjects, is if you have pruning rules or selection algorithms, then you can really cut out subsets of the combinatoric explosion and get results which you can then look at to see if they map onto the next hierarchical level. And in a number of cases, this has been quite successful and has led to the view of emergence. And this resonates with biologists for whom the evolutionary movement from one set of forms to another set of forms gets into this hypercomplexity and various rules. In this case, fitness rules would be used to select, but the general idea does resonate very well with biological theory, so that one can now do rather one can do rather interesting theory with these kinds of, so one can view the whole of the set of events from the Big Bang to human consciousness as a series of emergences. And one has, at least now, some theoretical tools to study these emergences, which one did not have 20 years ago. Everything in that domain has really happened in the last 20 years. However, that may give some comfort to both the religionists and the scientists, because since you have all of these emergences, and depending on how you look at it, the number might be between 10 and 10,000, You can't put these too precise. Then you have to have some theory of algorithmic pruning and algorithmic selection to go from one hierarchical level to the next. This is an area of science that's being passionately worked on by a number of people nowadays, but it's not solved. There are places where one can certainly see progress made this way, and it gives one theoretical tools for developing the biogenesis and evolution step by step from the information that is obtained reductively by the usual processes by which scientists proceed. So this, I think, has created something new that didn't exist. It or something similar has developed among the fundamentalists or the near fundamentalists a series of developments which are called design, theory of design, in which although they don't use these languages, they're regarding each one of these steps for which we are looking for natural laws, they are looking at as points of divine intervention. So it's a sort of God of the gaps theory that's coming among the fundamentalists. It provides more of grounds for dialogue, I would say, because this group interested in design has given up the idea of the inerrancy of the Bible, which really got stressed in the Arkansas case. That was I think there's been a lot of motion in some subgroups of the fundamentalists of this design school, which at least I think makes it possible to have more dialogue. As I say, I think they would use the God of the gaps for the emergences for which we're looking for rules of emergence. If I can give you an example of one emergence which we have some better understanding of how you go from physics to chemistry. And in that case, you start out with quantum mechanics as the physical reductionist laws which describe the action of the particles in the system, the energy levels, and so forth and so on. That is what you get to in a reductionist fashion. But that by itself would not give you chemistry. You have to impose on quantum mechanics the Pauli principle. And the Pauli principle is a pruning law. It selects from all of the possible states of electrons and nuclei those in which there are certain symmetry relations among the electrons, between the electrons. So it is kind of a law about how the whole is somewhat different than the sum of the parts. It works so well in physics, we don't think of it as a pruning principle, but it is, and it's perhaps the best understood. Well, I think those who are interested in design might think of the Pauli exclusion principle as a divine intervention between physics and chemistry. And again, that gives you the difference between the modes of thought that are involved in these various approaches to the problem. The other things have happened with respect in particular to the origin of life. You may know there are two schools of where the energy comes from the origin of life. There's the heaven school, which thinks it comes down as photons, and there's the hell school, which thinks it boils up in reductants and sulfur compounds and so forth and so on. I think there's been a move from the heaven school to the hell school, which the fundamentalists may or may not have some things to say about, but I think in terms of the scientists who are working on this, there's been some transformation in where thoughts about where life originated. And again, the nice thing about these biogenesis experiments is they're all have an experimental side to them, so that, for instance, I work with a group at the Carnegie Institute of Geophysics where we're doing organic chemistry at 500 atmospheres and 350 degrees centigrade to really get some insight as to what happens when things are bubbling up down at the rifts where the lava hits the water. And one of the nice results of that is it looks like we're getting Krebs cycle intermediates bubbling up under the right conditions, and that's a much better environment to think of life originating as some of the others that have been proposed. So biogenesis, the origin of life, is still very much a lively subject of interest, subject of experiment. It's been moved along lately since NASA has gotten interested in astrobiology, and that of course the origin of life is considered as part of the domain of astrobiology, so that's provided some research funding, which there wasn't much around in this area 20 years ago, so that the whole business of biogenesis, I would say, is likely to produce some really surprising, satisfying, and confirming, if I may give my own prejudice, and confirming results about the origin of life within the next 20 years. Thank you. Sure.
Brent Dalrymple, formerly of the U.S. Geological Surveys, and recently retired earlier this month, actually, brand new retiree over here, as Dean of Planetary and Atmospheric Sciences at Oregon State University, testified on the age of the Earth at McLean. Of his testimony, fellow witness Michael Roos has written, rounding out the scientific witnesses was G. Brent Dalrymple. He gave a quite brilliant disquisition on methods of dating the Earth. Now you have to imagine me saying this with an English accent, okay? One would not think such a topic could be all that intrinsically interesting. But Dalrymple gave this assumption the total lie. He held us absolutely spellbound as he talked of various dating techniques and how geologists compensate for weaknesses in one direction by strengths from another. My sense was Dalrymple was so good and so firm that he rather broke the back of the state's case. He had checked all the creationist arguments and shown in devastating detail the trail of misquotations, computational errors, out-of-date references, and sheer blind stupidity, which allows the creationists to assign the Earth an age of 6,000 years. After Dalrymple, the state seemed far less willing to tangle with witnesses. Please welcome Brent Dalrymple, who will speak on what's changed, remained the same in geochronology.
Well, thank you very much, Jeannie, and I'd also like to thank you for organizing this little reunion. It's hard to believe it's been almost 2 decades since the Little Rock trial, but as the old saying goes, time flies when you're having fun, and I've certainly had a lot of fun over the last 20 years. I'd like to take a look at a few of the things that remain the same to begin with, regards to the age of the planet Earth and related matters over the past 20 years. And let's begin with younger creationism, if we could have the first slide. Well, the small band of folks that call themselves creation scientists and are concentrated largely at the Institute for Creation Research in Southern California are still as active as they were 20 years ago, if not more so, but as far as I can tell, they haven't made much scientific progress in the last 2 decades. So far, they have yet to produce any scientific evidence or data whatsoever showing that Earth is very young, as they still like to claim. They continue their unsuccessful attempts to discredit the results of scientific calculations and data showing conclusively that the Earth, the solar system, the galaxy, and the universe are billions of years old, but they have not been able to come up with any number of their own and have yet to produce any credible objections to the scientific results. When one looks at what the creationists are doing in the way of research into the age of the Earth, it continues to have the same aura of goofiness that it had during the trial and since then. They continue to use some of the same arguments that they've used for decades and that have been refuted repeatedly by scientists. And while they have come up with a few new ideas, the quality of their science really hasn't improved a bit. Let me give you a recent example. In 1997, a group of ICR creationists established an activity they now call RATE, which stands for radioisotopes in the age of the Earth. Well, why rate? They intend to explain why isotopic dating methods give old ages instead of young ages for the Earth. In their view, these old ages must be wrong since they do not agree with their interpretation of the Bible. RATE consists of a $500,000 multifaceted research plan involving 10 different research projects that include helium diffusion, isochrons, radioactive decay theory, radiohalos and minerals, and some other subjects. Here's a brief explanation of their project on nuclear decay, taken verbatim from a recent ICR publication. Note that they call upon accelerated radioactive decay early in creation week and also as a consequence of the curse and the flood. Now, please don't ask me to explain this to you because I can't. Scientifically, it just doesn't make any sense. In fact, none of the RATE experiments make any scientific sense, and I think it highly unlikely that their outcome will enlighten us about the age of the Earth or any other important subjects for that matter. Well, what else has not changed? Here's a brief list. As you can see, the ages of the Earth, the Moon, the meteorites, the galaxy, and the universe are still measured in terms of billions of years. And although these numbers continue to be refined and made even more convincing by new data and evidence, I, like Harold, probably wouldn't have to change my testimony very much if I had to do it all over again today. Now, I don't want to give you the impression that nothing has changed since the Little Rock trial in 1981. There have, in fact, been a few changes. If you look around the room, you may recognize these four characters among you somewhere. These particular photographs appeared in Discovery magazine shortly after the trial. And I can't speak for my three colleagues, but as you can see by comparison, I haven't changed a bit. This slide is really me. That fellow who looks back at me from my bathroom mirror every morning is clearly an imposter. Another thing that has changed is the accessibility of information on the Earth's age. This is a book cover, a book I wrote and was published in 1991. And I'm not trying to sell you a book, but I am using this to point out that at the time of the Arkansas trial, there was no work available that summarized with any degree of thoroughness the evidence for the age of the Earth. In fact, this particular book, which appeared first in 1991, was the first comprehensive book on the subject since the National Research Council's 1931 book of the same title. Thus, in 1981, if you wanted to know something about this important subject, it was necessary to dig through an enormous amount of specialized literature, and that is something that's difficult to do even for a specialist in the field. The reason for this lack of attention was that the age of the Earth was so well known amongst geologists and astronomers that it was thought to be non-controversial and a subject of little interest. We now know better. There are other changes as well. Improved instrumentation has allowed us to make measurements with greater precision and in ways impossible 20 years ago. Because of this, the evidence for the antiquity of our cosmic surroundings has continued to accumulate, improving both in quantity and quality. And scientists are now beginning to unravel the sequence and timing events in the early solar system in considerable detail. I won't discuss all of the items on this slide, but I would like to mention just a few specifics. This is a photograph of the new SHRIMP RG housed at Stanford University and operated by Stanford and the U.S. Geological Survey. SHRIMP stands for Sensitive High Resolution Ion Microprobe, and RG stands for Reverse Geometry. The SHRIMP prototype was developed at the Australian National University in the 1970s and has now evolved into the RG model. It is essentially a very big mass spectrometer designed to analyze very tiny mineral grains. Ion probes use a beam of ions to ionize and analyze material from very small spots on the surfaces of solid materials. The RG has a mass resolution of about 18,000, which is partly due to its rather large size. Large ion probes, such as this one, make it possible to do uranium-lead dating on tiny spots within tiny mineral grains. I'd like to show you one example. It comes from the northwestern Canada, where the oldest rocks so far discovered on Earth have been found by Sam Bowring of MIT and his colleagues. The Acasta gneiss complex comprises a series of igneous intrusive rocks that contain tiny crystals of zircon. These rocks are similar to granite, but have a slightly different chemical composition and have been metamorphosed, that is, changed into something else. Now, zircon is an excellent mineral for uranium-lead dating because it's high in uranium and it's very low in initial lead. In addition, even when it's subjected to post-crystallization heating and partly altered, it often retains a memory of its previous age. This is a microphotograph of one zircon crystal from one of the Acasta gneisses, courtesy of Sam. You can see that it has a clear core and a cloudy, irregular rim. Actually, that rim is an overgrowth of younger zircon material that was added by a later metamorphic event. The little pits there, which you can see, are about 20 micrometers across and are where the ion probe analyses were done. The numbers are the uranium-lead model ages for each spot in millions of years. And as you can see, the oldest parts of this zircon are 4.03 billion years old. Sam Bowring and his colleagues have measured many spots on many zircons from a number of these rocks, and the evidence is that parts of the Acasta gneiss complex crystallized more than 4 billion years ago. That evidence is virtually irrefutable. At a meeting of the Geological Society of America a few months ago, William Peck from Colgate University and his colleagues reported ion probe uranium-lead ages of 4.4 billion years on zircon crystals from a sedimentary rock in Western Australia. These results were published in Nature magazine just a few weeks ago in a paper by John Valley, William Peck, and their colleagues. These Australian zircons represent the oldest minerals found on rock so far, found on the Earth so far. This is a photograph of another type of probe built in the mid-1980s. This probe uses an argon laser beam to melt individual crystals so that they can be dated by the argon-40, argon-39 technique of KER dating. This method is used to solve a variety of geological problems, and I'm going to show you one that at least you've all heard of. You've certainly heard that a large object from space, probably 10 kilometers or so in diameter, struck the Yucatan Peninsula 65 million years ago. This is commonly known as the KT impact because it coincided exactly with the end of the Cretaceous period and the beginning of the Tertiary period. And I'm sure you've also heard that this impact may have been responsible for the extinction of the dinosaurs, which lived throughout the Cretaceous but did not survive into the Tertiary. The timing of this impact was dated even before the location of the impact site was known, using this laser system to measure the ages of small glass spheres that were created by the impact and deposited in sedimentary rocks at the KT stratigraphic boundary in Haiti. One of these tektites, as they are called, is shown here. You can see it was originally spherical, that the outside has been altered over time to a white clay, and that fresh black glass still remains in the center. Using the laser system, it was possible to measure precisely the ages of 53 of these tektites and show that they were exactly the same age as the Cretaceous Tertiary boundary. These are the results. The different colors don't have any particular importance for this talk, so you can just ignore them. But notice how tightly the ages of the tektites are clustered around the mean of 64.5 million years. The upper histogram represents the ages of sanidine crystals found in a volcanic ash bed just a few centimeters above the KT boundary in Montana. And you can see that there is no significant difference between the two sets of ages. Well, this doesn't tell us how old the Earth is, but such measurements have allowed us to refine the geological time scale from the most recent to the base of the Cambrian, and all of it is far, far older than the young Earth creationists claim. Well, back to the age of the Earth and the solar system. This slide shows some very important data on meteorites recently summarized by Claude Alleg and his colleagues at the University of Paris. The publication was in 1995. The three red dots at the lower right part of the graph are some very precise lead ages on calcium-aluminum inclusions found in carbonaceous chondrite meteorites, the particular meteorite known as Allende. These CAIs, as they're known, were formed just when the solar system was isolated and were incorporated into Allende very shortly thereafter. They have a precisely defined age of 4.566 billion years. The graph also shows the lead ages of ordinary chondrites, which are another group of undifferentiated meteorites, and of achondrites, which are meteorites formed from lava flows erupted onto the surfaces of some of the larger planetesimals. Notice that the oldest chondrites are only slightly older than the CAIs, and the achondrites are only slightly younger than the chondrites. This is a summary of the conclusions one can draw from this lead age information gathered from selected meteorites that are very high in radiogenic lead. The solar nebula formed 4.566 billion years ago, followed within about 3 million years by the formation of the first chondrite parent bodies. A mere 8 million years after the solar system formed, planetesimals large enough to undergo internal melting were erupting lava flows onto their surfaces. This brings up an important point, which is illustrated by this slide. And the point is that it is often easier to measure small differences than absolute quantities themselves. For example, it may be that City Hall has measured the distances to your house and to the nearest fire hydrant using a vehicle odometer. And the best they can do is to resolve those distances within about 100 meters. Using a tape measure, however, it would be possible to measure the distance from your house to the fire hydrant to within a half a meter. The latter distance is much more precise and accurate than what you would get by subtracting the two larger numbers, and it would in fact be the number that your insurance company would most like to know. People who work with isotopes now have a number of chronometers based on isotopes with half-lives so short that they are now extinct. Nevertheless, these chronometers can be used to measure age differences between early events in the solar system. I'm not going to talk about all of these, but I do want to show you how these work by using the two chronometers in the highlighted bands there. Aluminum-26, which is ubiquitous throughout the early solar system, decays with a half-life of only 730,000 years. So within only about 5 to 10 million years or so after the solar system formed, it had all decayed away. CAIs contain relatively a lot of 26 magnesium, which means that they must have formed well before the aluminum-26 was gone. Some chondrules, which are the little mineral spheres that give chondrite meteorites their name, contain a little bit of magnesium-26, and some contain none. From that information then, and the amounts of magnesium-26, it is possible to calculate that these aluminum-rich chondrules begin to form within about 2 million years after the CAIs formed, and were still forming at least 3 million years later. Using the lead age of 4.566 billion years for CAIs that I showed you earlier, we can then put ages on these other events using the results from this relative chronometer. And that's what is shown at the bottom of the slide, the ages in years. Here's another one. Hafnium-182, which decays to tin-182, is another isotope with a relatively short half-life of only 9 million years. Now, hafnium and tin have some geochemical properties that make them very interesting. Tin, when it has a choice, will tend to follow other metals, whereas hafnium, when it has a choice, will tend to follow silicates. So now consider what would happen in a planet or in an asteroid that got hot enough so that it separated into a silicate mantle and an iron-nickel core. Most of the tin would end up in the core, and most of the hafnium would end up in the silicate mantle. If core formation happened before all of the radioactive hafnium were gone, as shown on the left side of the diagram, then the subsequent decay of hafnium-182 would result in an excess of tin-182 in the mantle and a deficiency of tin-182 in the core. I should mention that the tin-182 measurements, like all isotopic measurements, are usually made relative to a stable isotope, in this case tin-184. So we're always dealing with isotope ratios rather than absolute amounts. If core formation happened after all of the hafnium-182 had decayed away, then the tin-182 in the mantle and the core would be the same. Alex Halliday and his colleagues have been using this chronometer to determine the timing of early solar system events by measuring meteorites, lunar samples, and samples from the Earth. As you can see from the lower part in the blue bars there, the metal phase of chondrites and of iron meteorites is deficient in tin-182 relative to Earth. And many of the samples of the Moon, Mars, and achondrite meteorites, which are samples of lava flows, have an excess of tin-182, indicating separation of metal and silicate before all of the hafnium-182 had decayed away. The fascinating thing about this work, however, is that silicates derived from Earth's mantle and from carbonaceous chondrites have exactly the same tin contents. We know that the carbonaceous chondrites come from parent bodies that formed early in the solar system and that never did undergo separation of metal and silicates. And so that fact, and the tin compositions of the two are identical, indicates that Earth's core did not form until all of the hafnium-182 had decayed away, or more than 50 million years or so after the start of the solar system. Now, there's a lot more to this story than I can tell you in this short talk, but I hope that you can see by using these various precision chronometers that it's possible to begin to build a rather detailed timescale, such as this one here, for the early events in the solar system. The rate at which this field is advancing suggests that we may know even more about the precise timing of events that lead to the formation of the Earth, the Moon, and meteorites within just a few short years. But the fact remains that the age of the Earth, the stars over the past 20 years have really not changed. The Earth, the Moon, the meteorites, the Milky Way galaxy, and the universe are still measured in billions of years, not thousands of years. What has happened since the trial is that we have been increasing the amounts of data, refining the ages, and learning a lot more about the precise sequence and timing of events in the early solar system. And I'll end by showing you my favorite cartoon. The little angel here is saying to the deity, "The stars turn out just fine, sir. What do you want us to do with the little balls of dirt?" Thank you.